Okay, PARCA Technical Section 4.3 covers hexadecimal, signed numbers, and floating point numbers. So let's start with hexadecimal. Hexadecimal is a base 16 number system. It consists of 16 unique symbols. Those symbols are the numbers 0 through 9 and the letters A to F. Hexadecimal is useful because it can represent every byte as a 2 consecutive hexadecimal digit, and it's just easier for people to understand and read hexadecimal numbers than binary numbers, which are just strings of ones and zeros. Let's take a look at what that looks like. In decimal, if you were to count to 15, you would go 0, 1, 2, 3, 4, 5 all the way up to 15. In hex, you would count to 9, and then 10 through 15 would be A, B, C, D, E, F. In binary, 0 is 4 zeros. 1 is 001, 2 is 0010, 3 is 0010. So you can look at the graph and see how binary works good for computers, but people find it easier to understand hex. And of course, we all know decimal from our days in elementary school. Signed numbers. A signed number is a number that's preceded by a plus sign to indicate a positive quality and a minus sign to indicate a negative quality. So the most common usage of positive and negative numbers is in measuring density of objects, particularly on a CT image. So density is measured in Hounsfield units. Water is a density of 0 HU or 0 Hounsfield units. Any object that is denser than water has a positive number. Like bone. Bone is denser than water, so it will have a positive density value. An object that is less dense than water has a negative number. For example, air. If you're doing a CT of the lungs are full of air. If you put your cursor over and measure the density in the lungs, you'll get a negative number because air is less dense than water. So that's the most common and most likely place you see positive and negative numbers in the radiology workspace. Floating point numbers. The people that make the PARCA test love the concept of floating point numbers, and they put lots of questions around floating point numbers into their exam. A floating point number is a positive or negative whole number with a decimal point. Okay, so 1.2 is a floating point number. 6.8, anything with a decimal point is a floating point number. The Institute of Electrical and Electronics Engineers, that is a tongue twister. The Institute of Electrical and Electronics Engineers sets the standards for computer engineering. The common standard for binary representation that's determined by IEEE is floating point numbers. The most common representation for real numbers in computing as determined by IEEE is the IEEE standard 754. All of that means that these guys at this organization, IEEE, said, hey, we're going to just express binary representations as numbers with decimal points, and we're going to put that into a standard and number at 754, and that's what everybody's going to use. And that is what you need to know about floating point numbers and hexadecimal and signed numbers. Thank you for watching.